Wave scattering is a general physical process where waves are forced to deviate from a straight trajectory by one or more paths due to localized non-uniformities in the medium through which they pass. In this experiment, we will work on the finite difference time domain method, in which we will see the effect on wave bending properties by changing the relative size of the obstacle to wavelength. Scattering occurs when size of optical obstacle is larger than the wavelength. Particle-particle collision between molecules, atoms, electrons, photons, and other particles leads to change in the direction of molecules. The angle through which sunlight scatters varies inversely with wavelength. Blue skies, red sun during sunrise and sunset, white clouds are the result of scattering. Meep Meep is a 1D simulation software used to simulate the time domain electromagnetic waves in 1D, 2D, and 3D coordinates. It uses a techniques called FDTD method, which we are going to use here to model the field patterns. We will be using this software for our purpose. This is the code of Meep, where we can see the size of the block is much larger. Here we will be observing wave bending properties when obstacle size is comparable with wavelength. This phenomena is known as diffraction. It occurs when the size of obstacle is comparable with wavelength. In this case, light goes around the obstacles. Diffraction occurs when wave passes through small openings around the obstacles, and small openings, single slit, and geometrical optics are also their example. This is the code of Meep, where we can see the size of the block is relatively comparable. Now this GIF shows here the effect on light of wave bending when the obstacle is small as compared to the wavelength of light. This code is the Meep code, where we can see the size block is relatively very small. Thank you.